Welcome everyone to this video tutorial on data mining. In today's class, we will be discussing the complete list agglomerative hierarchical clustering or max clustering, hierarchical clustering algorithm. So as you can see in the last video that how can you implement single link agglomerative hierarchical clustering, in which we are going to take the minimum value whenever we are going to merge the two cluster. We are going to take the minimum value between the two cluster. Fine. So now, as in this video, we will see how we are going to perform complete link agglomerative hierarchical clustering or max, which is known as the max, in which whenever we are going to merge the two clusters, we are going to take the maximum distance between the two clusters or the furthest points between the two groups of values. So let's see with the help of the example. So these are the data set. There are 6 students, you can say, and the 6 students are securing marks in 2 different subjects. So this is the marks of the first subject and this is the marks of the second subject. Okay, so in the second subject everyone is scoring as a value 0. So from this, since there are 6 students, so you are going to make a distance matrix of 6 by 6 where every individual student will be considered as a cluster. So as you can see, this is the 6 by 6 matrix in which every student is considered as a cluster. A is a cluster, B is a cluster, C, D and E and F is a cluster. So these 6 points will be considered as an individual cluster. So how we were going to find the distance? We are going to take the help of the Euclidean distance. We are going to take either the lower triangular matrix or the upper triangular matrix, because distance of A and B will be equal to distance of B and A, since Euclidean distance is a metric which satisfy the property of symmetricity. Fine. So how will you find a distance? So Euclidean distance is given by the formula square root of x2 minus x1 whole square plus y2 minus y1 whole square. And in this example I have shown you how to find the distance of A and B. So distance of A and B will be equal to, if this is x and these are x attribute and this is y attribute, 18 minus 22 square plus 0 minus 0 square, ultimately there is a root over. So it will be square root of 16, which will be 4. So distance of A and B will be 4. So like this you can calculate the distance of all other data matrix. So you will get a data matrix of 6 by 6. Now we are going to perform the clustering or the merging operation. So whenever we are going to do the clustering, we are going to take those class points to be together in which distance is minimum. If you look at the whole matrix, this is the point where distance is minimum. So you can take the values corresponding to the rows and corresponding to the columns. So we can take C and D to be merged to be one cluster. So in the next data matrix, updated matrix, it will be 5 by 5 matrix where C and D will be combined into a single matrix. So now this scenario comes where we have to find out the updated matrix, because earlier it was 6 by 6 matrix, now it is 5 by 5 matrix. So to find out the updated matrix, we will take the maximum value between the two clusters. For example, to find the distance between A to CD, we will take the distance from A to C and we will take the distance from A to D, and we will take those distance which is maximum. Okay. So the distance from A to C is 25 and A to D is 24. This is 25 and this is 24. Now we will take the maximum, which is 24. So in the updated matrix, as you can see, the distance is maximum distance is 25. So 25 will be replaced by here. Similarly, to find the distance between B and C, D, we will take the distance between B and C and B and D when we will consider the maximum distance. So here you can see the distance between B and D is 20. Okay, and the next is the distance between B and C. So B and C is 21. So 20 and 21, maximum is 21. So 21 will get updated here. So like this you can calculate the distance between E and CD and F and CD. Fine. So from this matrix, the 5 by 5 matrix, as you can get from the distance by considering the maximum distance between two clusters, again we have to find out the minimum value. As you can see, the minimum value of the updated matrix is 2. So 2 corresponding to the data object E and F. So in the next thing, we are going to merge two objects E and F into single cluster. So next the matrix will be 4 by 5 matrix. So as you can see here, this F and E are merged. So how can you find out the updated matrix? So updated matrix will be found using the maximum distance between the two clusters. So to find out the distance between A to EF, so this is A to EF. So as you can see, you have to find the distance between A to E and A to F, and we have to consider the maximum distance. So as you can see, the maximum distance from A to E is 9 and A to F is 7. So 9 and 7, what is the maximum value? 9. So it will be updated by 9. Then you can see from CD to EF. So to find the distance between CD to EF, we have to find the distance from CD to E and CD to F from the previous matrix. So this is the this is CD to E is 16 and CD to F is 18. So what is the maximum value? So it will be 17. So it will be updated by 17 only. Okay. So this will be the updated matrix. Okay. So it is printing mistake. It should be 18 only, because CD to EF is 18, as you can see from this video. So this is 16 and 18. So there is a mistake here. So it will be 16,18 and it should be 18. So there is a mistake over here. Okay. So next thing, we can go to the next matrix. So to find out the next matrix, again we have to take the minimum values. Now from the matrix you can see this is the minimum value. So next A and B will be put in the same cluster. So it will be a 3 by 3 matrix. So this is the next matrix where A and B will be put in the single cluster. So this is the 3 by 3 matrix. So to find out the distance, we will taking the maximum distance. To find the distance from CD to AB, we will consider the distance from A to CD and B to CD, and we will take the maximum. So from the previous matrix we can see, so to from CD to A it is 25 and C to BD it is 21. So it will be 25. So the maximum distance is 25. So we will be putting here 25. Next, to find out the distance from EF to AB, we have to take the distance, maximum distance from A to EF and B to FB. So as you can see, A to EF is 9 and B to EF is 5. So it will be ultimately maximum distance will be 9. So this is the updated matrix. Again from this matrix we have to take the minimum value. What is the minimum value? 9. So again A, B and EF will be combined here. So it will be a 2 by 2 matrix. So where this will be combined. So to find out the distance from CD to AB, EF, we have to find the distance from CD to AB and CD to EF, and we have to take the maximum distance. So CD to AB is 25 and CD to AF is 18. So it will be updated by 25. So next we will get this matrix, and from this matrix we can combine all the matrix. So it will be a single cluster. So like this you can perform the maximum or the completely hierarchical clustering by updating the value in the updated matrix by considering the maximum value between the two clusters. So if you see the dendrogram here, what we can say, first we are combining. So if you see the matrix, first we are combining what? C and D with the value 1. So here C and D is combining with the value 1. So it is in this place. Okay. In the next place you can see, after combining C and D we are combining what? E and F. E and F is combined with the cluster cut value 2. So E and F is taken here as the value 2. Next A and B are combined. So A and B are combined at value 4. So A and B are combined here at value 4. So first 1, 2 and then 4. And after this EF and AB are combined. EF and AB are combined at EF and AB are combined at the matrix 9. So it will be combined here at 9. So ultimately the ultimate matrix is combined here by at 25. So it will be at 25. So as you can see, whenever you are representing the dendrogram, it is always in the increasing order: 1, 2, 4, 9 and 25. So this is how you have to draw the dendrogram for completely hierarchical clustering. So hope you like this video. Thank you very much.